Hello, welcome to my channel. In this video, we are going to discuss the vector projections. If it's your first time of viewing, ensure you subscribe to my channel so that you don't miss any content. Okay, now before I solve this particular question, I'll need you to understand actually what these projections are all about. Take for instance, I have two vectors. Let's say vector A and vector B. Okay, I have vector A and vector B. So this is my vector B, for instance, and this is my vector A. Okay. Now, if I have a torchlight here, and if I light this bulb, there will be a lot of rays of light, of which one of the rays will go directly to hit this particular plane A. Okay, there could be so many rays of light, of which one of the rays will go directly to hit upon this particular vector. Now, which will be perpendicular to it, forming a right angle. Now, this has caused this vector B to be projected on vector A. So this is the projection. This line, if here is, let's say, C. So this C to this horizontal plane here is the projection. And this projection will cause a shadow. This particular plane, this particular projection will now cause a shadow to lie on this vector A. So this A here is the actual projection we are talking about, the vector projection. Now, to get this particular length, which is vector projection, an angle has been formed between this vector A and vector B. Let's say angle alpha now. From here, we have our adjacent, and here is our hypotenuse. Okay, so adjacent to hypotenuse will give us cosine. Hence, cosine alpha will give us adjacent, which is A over our B. Okay, I can say modulus of A over modulus of B because they are sides. Okay, now if I cross multiply, you see that modulus of A will give me modulus of B multiplying cos alpha. If I like, there could be some part of A, because this is the whole length of A, there could be some part of A moving, maybe having the size from here to this particular point, which can be a unit vector of A. Okay, it can be a unit vector of A as small as that. So the modulus of A, which is the projection we are talking about, it can be modulus of A, as the unit vector of A multiplying unit vector of B cos alpha. The reason I'm putting this is that unit vector has a magnitude of 1. And when I use 1 to multiply anything, I'm still getting the same thing. So this unit vector I'm using here will not have any impact on this particular equation at this point. Let's say equation 1. This is equation 2. They are still the same thing because this is a unit vector having a magnitude of 1. Now remember, from the scalar product of two vectors or dot product, you can watch it. Go to my playlist and look for vectors. My last video on vectors talks about the scalar or dot product. You can see that from the video that two vectors A dot B multiplying each other is something as modulus of A dot modulus of B dot the cosine of angle between them. Now, which means if I make my cos alpha subject of the formula here, I'll have that cos alpha will be the same thing as A dot B all over modulus of A dot modulus of B. So I can use this value here and plug in this equation 2 to get something unique. So I'll wipe here to continue. So from here, this equation 2, wherever I see my cos alpha, I'll plug in A dot B over modulus of A dot modulus of B. So from here, the modulus of A will now be not just the modulus, the projection will be modulus of unit vector of A dot modulus of B here dot cos alpha will now give me A dot B over modulus of A dot modulus of B. That's what I will get because this has replaced cos alpha. Now this can cancel this. This A modulus of A, which is the same thing as projection of B on A, that projection of B made on A, that is the equivalence, will now be equal to this multiplying a dot b all over modulus of a. Now, if you watch my videos on unit vector, you see that unit vector of a is the same thing as a over modulus of a. So look at a over modulus of a, which I can plug out and use unit vector of a to represent it. Okay, so this will now be modulus of unit vector of a times, because the whole thing has turned to this modulus vector of a, then times vector b here. Okay, now unit vector times unit vector is still a unit vector, so we can just write that the projection of b on a, so p1, let p1 be the projection of b on a, will now be equal to modulus of okay, or just I can write b first, will be b dot unit vector of a, as simple as that. So dot unit vector of a, this will give you the answer. Similarly, assuming I have another projection b2 which a is now making on b, this one is the one b made on a. So if a is making a projection of b, if I reverse that direction, it means it will be a times unit vector of b. That's just it. So if they tell you projection of b on a, use this, because a is having the impact on the projection is on a, so you have a hat, then on b it must be hat, the one that has the impact must be at the hat. So we've just used this little thing we've learned to solve this particular problem. So to tackle this problem at hand, we are given this and we are asked to get the projection of a on b. A on b, the one that is suffering now is b, because the projection is on b. Therefore we use the second formula because it is on b, the impact is on b. So the required projection, let's say p2 or p1 or anything you want, will be a multiplying the unit vector of b. Okay, now the vector a is already given, so let us get the unit vector of b. And look at b here. Unit vector of b, the unit vector of b is the same thing as b over modulus of b. So we know our b, let us get the modulus of b. Modulus of b is the same thing as root, this is our x, this is our y. The coefficient of x is 1 squared, so we have 1 squared minus 1 squared because it's negative, plus our y is 4 squared. We have to, because the formula is root x squared plus y squared, if you watch my videos on modulus of vector. So modulus of b will now be square root of 1 plus 16. So modulus of b is giving us square root of 17. Okay, so I'll wipe here and continue. Okay, now since I've got the modulus of b, let us complete the projection, the unit vector of b, sorry. So unit vector of b will now be b. Our b is minus I plus 4j all over modulus of b from the formula is just root 17. This can be written as 1 over root 17 multiplying I plus 4j. That's the unit vector. So finally, the required projection, which is p2, will now be a dot b, and our a is 2I plus 3j. Okay, multiplying I plus 4j into 1 over root 17. I let this to be outside so that these two values can easily be multiplied. Remember my videos on dot product where I taught you how to multiply vectors like this. Hence p2, I'll open the bracket, 2I times, remember this is negative, okay. Now 2I times minus I will give us negative 2I squared. 2I times 4j will give us 8ij. 3j times negative I is minus 3ij. And 3j times 4j will give us plus 12j squared. Remember, we have 1 over root 17. Okay, so our P2 will now be minus 2I squared plus 8ij minus 3ij is 5ij plus 12j squared multiplying 1 over root 17. So P2 will give us, remember that I squared is 1, j squared is 1, but ij is 0. When they are different, ij is 0. I've worked on this. Check my video on dot product. So I squared is 1 minus 2 times 1 will just give us minus 2. This is 0. Ij is 0. So 5 times 0 is 0. It has gone. J squared is 1. 12 times 1 will give us 12. Okay. Then multiplying 1 over root 17. Now I'll have to clean here again to complete the equation. Minus 12 plus 10. Minus 2 plus 12 will give us 10. So the projection P2 is just 10 over root 17, which I can rationalize if I want. So I will say times root 17 all over root 17. So finally the projection will give me 10 root 17 over this times this will give us just 17. Okay, this is just the required projection of vector A on vector B. If you've enjoyed what you've watched, kindly subscribe to my channel so that you don't miss anything coming on the topic vector. Thank you so much.